Yes, student. Now we are starting our chapter group 15th elements, that is belongs to nitrogen family. Students, in group 15th element there are nitrogen, phosphorus, arsenic, antimony and bismuth. Okay, nitrogen occurrence occurrence. Okay, it is found in atmosphere. About it forms 78% of volume of atmosphere. Getting that is the most of the percentage is of nitrogen gas. It exists in diatomic molecular form. That is what N2, diatomic molecular form. Also it is present in various type of compounds, various types of ores like the nitrites ore, nitrates ore, etc. Phosphorus, it exists in P4 form. It is because it is highly reactive. Okay, its allotropes are also present. It is of white and red phosphorus. White phosphorus is highly reactive, therefore it does not exist in its free form but exists in compound form. Okay, arsenic, antimony and bismuth, they are very less abundant element, and mainly these elements are exist in the form of their sulfides ore. Okay, so this is about the occurrence. Now atomic properties. Atomic properties. In atomic properties, first we will deal covalent radius. Covalent radius, or you can say ionic radius. Ionic radius for a particular oxidation state. Student, in atomic properties, first point covalent radius is dealt in two form. First one, along a period. Along a period, that is what, on moving from left to right. But student, here we have to compare the covalent radius of 15th group element, okay, with the adjacent group element, that is what, 16th group element and the 14th group elements. Student, from the general concept you know that on moving from left to right, number of proton increases by 1 regularly. Therefore nuclear attraction force increases. Being nuclear attraction force increases, the atomic size decreases. Okay, that means what? That means the 16th group element have the smallest size, while the 14th group element is of biggest size as compared to 14th, 15th and 16th. There is no exception at all, therefore no need to discuss more, you know from the previous class. Okay, number 2, down the group. Down the group, that is on moving from nitrogen to bismuth, this is called down the group. Okay, down the group, covalent radius what, increases. Covalent radius increases. Okay, but increase is not regular. But the increase is not regular. How can we say? Like here, if you write N, P, As, Sb and bismuth. Okay, the covalent radius in picometer is 70 picometer. This is 110 picometer, but now it is 121 picometer. This is 141 picometer and this is 148 picometer. Observing the radius with a particular value, we can simply see here N to P, there is regular increase in the covalent radius. This is due to introduction of one shell. But after P to AS, Again covalent radius increases, but the increase is only of 11 picometer. Increase is only 11 picometer. So what is the reason behind it? The reason behind the irregular increase in covalent radius is the introduction of 10 electrons, okay, in d orbitals. You know, student, when the electron enters in d subshell, now the poor shielding effect is shown by the d subshell. Therefore, the valence electron, that is 4s2 4p3 electron, experience stronger nuclear attraction force. Therefore, the size decreases. But being one shell increases and the strong, that is effective nuclear attraction force, tend to decrease the size, result into increase in covalent radius, but is irregular, that is very less, that is as compared to N2P, there is lesser increase in the atomic or covalent radius. Now, if we judge from AS to SB, we can see here there is 20 picometer in increase. Okay, why? Again the d subshell introduces, but already it affected the atomic radius, and therefore now it doesn't affect more. Thus now the increase in covalent radius is little more as compared to phosphorus to arsenic. But in the case of SB, that is antimony to bismuth, now the picometer increase is only 7 picometer. It is because at sudden there is introduction of, say, 7, this is 15, this is 31, okay, sorry, 33, and now 51, and now 83. Means what? The proton increases by 83 numbers, and these 83 number, that is 32 number of proton, okay, increases the nuclear attraction force, and therefore there is very little in atomic size or covalent radius. Student, the second property is the ionization enthalpy. Student, you know that the ionization enthalpy is mainly depends on three factors: atomic size, ionization enthalpy, and stable and configuration, that is fully filled and half filled configuration. So again, in ionization enthalpy, very first we will discuss what? Along a period. Along a period, that is on moving from left to right. So we will judge here three things. What? 14, 15 and 16. Student, you know that as the atomic size decreases, nuclear attraction force increases. Therefore, there should be increase in the ionization enthalpy. Why? It is because ionization enthalpy is inversely proportional to atomic size. So, what we can say? The 16th group element should have highest ionization enthalpy as compared to 14th group and 15th group. Now, but there is exception. What is the exception here? Student, you know that the general outer electronic configuration we have written for 15th group element is what? NS2 NP3. Okay, what is this? NS2 NP3. That is what? The p subshell have half filled configuration. P subshell have half filled stable configuration. Half filled stable configuration. So ionization enthalpy of 15th group element is highest. Element is what? Highest. Now, how it is highest? It becomes 14th group, 15th group and 16th group. So, due to half filled configuration, now the ionization enthalpy of 15th group is more than 14th group and even more than the 16th group. This is due to the exceptional configuration. Okay, now student, the second point we can discuss about down the group. So again I told you ionization enthalpy is inversely proportional to atomic size. As we have seen the irregular increase in the atomic size, and therefore consequently we will observe irregular decrease in the ionization enthalpy. That is, from N to P there will be other magnitude, but P to AS there will be other magnitude. So down the group ionization enthalpy decreases, but the decrease is not so regular because again it depends on atomic size.